Okay, now we need to remember when we're talking about the discriminant, we first need to remember the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, there is a name for this part under the radical sign. The b squared minus 4ac is what is known as the discriminant. Now, we can calculate a discriminant for any equation, and that information gives us some details about the graph of the function. Let's take a look at an example. Let's say we were asked to calculate the discriminant of, let me change colors here. Let's say we were asked to calculate the discriminant of x squared plus 5x plus 3 equals 0. This is a simple one. Now, since I just have an x squared there, my a would equal 1 because there is a number there. It's a 1. You just don't see it. B, because I have just one x squared, is equal to 5. And C is equal to 3. To calculate the discriminant, we simply have b squared minus 4 times AC. So in our case, we will have 5 squared minus 4 times 1 times 3, or 25 minus 12, which is equal to 13. So my discriminant for this equation is 13. Now let's look at what that tells us. I'm going to hand draw an x and y. Here, there's my x. Here's my y. And let's talk about this. If I have a positive discriminant, okay, this is when my discriminant is positive. It crosses the x-axis at exactly 2 places, which means it has 2 solutions. 2 real solutions, okay? 2 real solutions. Let's say my discriminant, when I calculated it, was equal to 0. Say my discriminant is 0. That means that it touches the x-axis in exactly 1 place, and it has 1 real solution. Better go over here and sneak in the word real there. Now, the other case is when my discriminant is negative. If my discriminant is negative, it does not intersect the x-axis, and it has no real solutions. So, let's go over that again. If my discriminant is positive, it intersects the x-axis in 2 places and has 2 real solutions. If my discriminant is 0, it touches the x-axis in 1 place and has 1 real solution. If my discriminant is negative, it has no real solutions.